Hi everyone, this is Ramakrishna. Welcome to my channel. In this video, I'm going to discuss linear algebra question number 28, section B 3 marks question from CSIR net June 2017. And the question is, let capital A and capital B be real invertible matrices such that AB is equal to minus BA. Then we have to verify the four options. Option number 1, trace of A is equal to trace of B is equal to 0. Option number 2, trace of A equal to trace of B is equal to 1. Option number 3, trace of A equal to 0, trace of B is equal to 1. And option number 4, trace of A is equal to 1, trace of B is equal to 0. Okay, this is a problem about trace of a matrix. So recall properties of trace of a matrix. First property is trace of A plus B is equal to trace of A plus trace of B. And second property is cyclic property, that is multiplication. Trace of ABC is equal to trace of CAB is equal to trace of BCA. Here in the multiplication, cyclic permutation will be allowed. Random permutation is not allowed. That means trace of ABC is equal to trace of CAB. Similarly, trace of BCA. So we have to take the matrices cyclically, not randomly. Okay. Now, in the given problem, we have to check the options. So therefore, trace of A is equal to, this can be written as trace of A into capital I, where capital I is an identity matrix. And in the problem given that A and B are real invertible matrices, so here capital I can be written as B into B inverse, because B is an invertible matrix. So this is trace of capital A into B inverse. Okay, so this is equals to trace of AB into B inverse. So this is equal to, and given that AB is equal to minus BA, so in place of AB we can write minus BA. So this is trace of minus BA into B inverse. Okay, so now taking minus out of the trace, we get minus trace of BA into B inverse. Now by using cyclic property of trace, we write minus trace of B inverse BA. This is by using property 2, that is cyclic property of trace. Okay, so minus trace of B inverse BA. So this is minus trace of B inverse B is nothing but identity capital I into A. So this gives minus trace of capital A. So we have trace of A is equal to minus trace of A. So therefore we can write trace of A is equal to minus trace of A. Okay, trace of A is equal to minus trace of A, which implies trace of A plus trace of A is equal to 0. That is 2 times trace of A is equal to 0. That implies trace of A equals to 0. So similarly we get trace of B equals to 0, because A and B are both real invertible matrices. So similarly we get trace of B is also equal to 0. Therefore option number 1 is correct. Is it clear? I hope you like this video. If you like the video, please share, subscribe. Thanks for watching.